Suppose we're running the PID application in manual mode at some low frequency or even 0 Hz, and we have our set point at the 6 psi we've been using in this series of videos. And then we switch to auto mode. What happens? Well, PID is going to try to get the process to 6 psi as fast as it can, which usually means it'll send the motor straight to its max speed until the pressure gets close to its desired value, and then back off on the motor speed so the process settles out right at the set point. Now, for our little pump station demo, that's no big deal. But if you have a process that could be dangerous to people or even damage the machine if the system suddenly jumped to max speed, well, then it is a problem. That's where Bumpless Mode comes in. When switching from manual to automatic mode, it simply reads the current process variable and puts it in the set point. So when PID starts, it sees the process variable and the set point are the same, and it just goes about the business of maintaining that motor speed. The operator can then safely increase the set point to the desired level. So Bumpless Mode 0 is where the Bumpless Mode is turned off and PID does everything it can to get to the set point as fast as it can, which for some processes can be dangerous. Bumpless Mode 1 is what we just described. The set point is set equal to the process variable upon enabling PID to prevent PID from possibly driving the motor straight to full speed. The CFW series of drives also lets you control the transfer when exiting PID. Similar thing. Suppose PID is reliably holding the process at some level, and when you switch to manual mode, you don't want any sudden changes in the motor speed. Bumpless Mode 2 sets the manual set point to whatever the current drive frequency is, so when you make the switch to manual mode, the motor just keeps spinning at whatever speed it was already at. Again, preventing a sudden change. The operator would then safely adjust the manual set point to whatever it needs to be. Bumpless Mode 3 enables smooth transitions in both directions. Now this is important. Bumpless Mode only works if the set point is being controlled manually by the drive's HMI, or by a COM card, or by the electronic potentiometer option. Bumpless doesn't work if the set point is controlled by an analog input or digital inputs, which makes sense because there's no way the software can override those hardwired inputs, right? And I should point out that I'm using the term bumpless because it's the most common term for this industry. But you won't find the word bumpless in the WEG programming manual. They prefer to call it automatic adjustment of the PID controller set point. Click here to see the rest of the videos in this series. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's free award-winning support options.